Okay, well, it's I was going to say 1:45. It's 45 past the hour wherever you are in the world. The highest people that registered after the US, the most people that registered for this conference were from the Netherlands. So I had no idea what time it is there. A lot of Europeans.
Well, hopefully they've stuck around for us.
Yes. But anyway, these are the guys from Tremor Video, and they've been using Talos for quite a while. Great guys. So I will hand it over to BJ and Sean.
Hey, thanks, Steve. Appreciate it. Name here is BJ. I run the infrastructure DevOps team. It's kind of a new team we put together ever since we acquired an ad tech company called Amobi. Tremor is an ad tech company. We run an SSP, a DSP, an exchange, and various other ad tech related services. And basically, we're faced with a ton of traffic, and we'll show you guys kind of what we're doing to get there. Sean, go ahead if you want to introduce yourself too.
Yeah, I'm Sean Larvik. I do DevOps, which is in Tremor's view, just a little bit of everything pretty much. I do a lot of automation scripting, doing pipelines and working out how to kind of fit together all of the bits and bobs that we acquire throughout the years.
All right, cool. Yeah, so just to tell you guys a little bit about what we do, you could call us the flux capacitor for online video advertising. We basically enable publishers and advertisers to work together, mostly for pre-roll video ads, although we do work in other parts of the landscape. And in order to make that happen, we have to process billions and billions of requests during the course of a day. That means when somebody clicks on a video to watch, basically we need to help get a certain ad to play before that video, the actual video they want to watch happens. And there's a lot of high-tech stuff going on, and that all has to happen in usually less than 100 milliseconds. So we have to deal with tons of traffic. We're reporting back what's going on. There's bidding that happens. So ad placements happen, and we track campaigns and so forth. And right now, to deal with that, we mostly operate on-prem, but again, we've been able to move some of these services into the cloud and back and forth, and we do a lot of migrations through, whether it's an acquisition or whether we're just trying to improve latency or test things or whatnot. So it's kind of similar to high-speed trading. There's a lot of traffic, a lot of bandwidth. So that's kind of what we do. Let's see here. So some of the challenges, obviously there's a low latency need. We can't be wasting time. We need to be able to service requests as quickly as possible. That means even requests that flow through our stack. So microservices talking to each other, things like that. It's not just about getting responding back out to the internet or whatnot. It's basically, the full stack needs to be fast. And part of that is obviously operating on bare metal. And if we do operate in the cloud, we need to also account for any overhead in the cloud, like hypervisors, things like that. So all those microservices have CPU and memory requirements and different needs. That also affects, how many of a certain pod we may want to run on hardware. It also depends on the type of hardware certain microservices are running on. We need to make sure that those pods are placed on the right type of hardware. And we need to be able to scale those services independently. So Kubernetes is a great fit for that. But again, doing all this and being able to service that many requests when you're basically throwing out a lot of what you're pulling in, it's sort of like panning for gold. That can get really expensive. So we needed to be able to find a way to run this on bare metal and, the majority of it on bare metal and at times burst, which we're still kind of working on. So around 2016, at that point, we were deploying our apps sort of one-to-one, where we had hardware built out and we deployed boxes and each box ran a certain service, and that was all done with Ansible. We used Ansible Tower at one point, then we moved to AWX, and there were servers all over the place. We had servers on the West Coast, East Coast, out in Europe, all over the place. And a lot of those services really didn't use those boxes to their full capacity. So we had a lot of wasted CPU and memory. It was really annoying when you needed to try to scale one service, because then you had to figure out where you had boxes available and then rebuild them and then rerun the service or scale the service that you want to scale onto those boxes you just wiped. So it was really inefficient. You know, begrudgingly we had to deal with it and to get through it, but we knew that there was a way that we could do this better, and we knew we could do that with containers. So that idea kind of came into our head, and over time we knew we would want to get there, and that's when we started looking at you know, what we could do with Docker. And so in the beginning, I think this was right after attending DockerCon 2017. We had an idea to maybe just dip our toes in the water with Docker Swarm. And one of the things that we were doing at that point, I believe, from what I remember, because boy, it's hard to remember that far back, but I think at that point we were already running console. So we were able to deploy a service on bare metal, have it advertised to console, and be reachable via that FQDN and DNS or via an API call. So the goal with Docker Swarm was simply to be able to get a container running, have it scheduled on a piece of hardware, and then have that container actually get its own IP address. And that's a fully routable IP address. And by doing that, we could actually have that container, not a pod, but back then it was just a regular old container running in Swarm, come up with its own IP. It's completely routable. There's no ingresses. There's no proxying, anything like that. And be able to have that console service be basically loaded between bare metal and or old school legacy bare metal and a container. And so we could do a slow roll of services into, at that point, Docker Swarm. We didn't really get too far with that. It had some limitations. Pods were obviously a lot nicer. The ability to do sidecars and a whole lot of other things. So we decided to move into a hand-built cluster using Kubeatom, where we basically generated all the certs by hand. We generated all the certs for etcd, all the certs kubelet, and so forth, and pieced together, just following the instructions, our first cluster with Kubeatom. And I can't remember how many nodes we scaled that to, but we did actually end up putting that cluster into production. Unfortunately, I think a year later, we didn't really pay attention to cert rotation, and the cluster certs expired. So we went through what it was like to actually deal with a failed API, Kubernetes API, through the fact that the certs expired, which wasn't awesome.
Internally, we called it the cube explosion. That was
known as the infamous cube explosion. So we decided at that point that maybe it wasn't a great idea to hand build these, and we needed to find some other way to do it, again on bare metal. So at that point, we turned to that was, as Andrew said, that there were a lot of questions about cert rotation with Talos. So that was another reason we'll get to for why we chose Talos. But anyway, we were running KubeSpray, and that did okay. We were able to deploy clusters using that. We noticed that the bigger the clusters got, the longer it would take to add nodes and to even build a cluster from scratch with X number of nodes. So if you're getting up to 100 nodes, the thing would take 2 hours. And we even tried setting the fork levels, parallelism and so forth higher, and we never really had a lot of luck with that. So unfortunately, we were stuck with this for a while, until the day that I actually decided to go on the Kubernetes subreddit on Reddit and saw a post that Andrew had made about Talos. So again, just kind of getting back to our architecture, we deploy most of our apps into Kubernetes using GitLab with GitLab CI/CD. We basically just use that one platform to do it all. We advertise that service to console, so we'll advertise any deployment out to console. So if they're running on bare metal already, it's very easy to co-announce or advertise your service to console, regardless of where it lives. And to do that, so every pod has its own IP address and a routable IP address. Again, avoiding ingresses, avoiding any proxying of any traffic, because we want low latency. We don't want to involve more load balancers where we don't need them. We use KubeRouter to effectively announce the pod IPs and peer to the top of rack switches to make sure that those IPs, those ranges are advertised out. And I think there were some other folks that did something similar earlier today. I think Nokia is doing a crazy version of this where they do almost everything all layer 3. But This was done with KubeSpray. We were using KubeRouter, basically this model right here. So what we needed to do was at least test Talos and make sure it could do the same thing. So we had sort of parity with the function of how these clusters ran. So at that point, we decided to give Talos a shot and just start out with the how-to, figure out how to install it, figure out how to sort of bootstrap it, understand how Talos talks to its own nodes, how you configure a box to be, whether it's a control plane or whether it's a worker. And obviously, a lot of the reasoning behind why we chose this was because of the fact that we're big fans of cattle, not pets. And we don't want to deal with these disparate machines failing or having to rebuild an etcd node or deal with all the management overhead of these pet cluster nodes. So I really think that Talos gives you that effective, like appliance-like management ability, manageability, I guess. So you really don't have to worry about what's going on. You can kind of just have it build a control plane and you don't have to think about it. And again, this is a small team. I mean, we operate at this point, I think it was just 2 or 3 people working on this project. And again, this was just part-time. This is just one of the things we do on the side. So basically, that's really why we went with this. Also, the fact that it's secure, roots mounted read-only. It was kind of a dream come true. We didn't want developers on any of our boxes if we could avoid it. So this was a great way of stopping any of that from happening and really forcing people, not forcing people, but enabling people to, through other tools, manage their applications, not really worry about having to deal with pet hardware or any of the extra overhead that goes along with that. And there's a question from Dinesh, looks like. Moving over to V6 for potted. Oh, are you talking about IPv6? That's what I'm thinking. We've talked about IPv6, but haven't really done a lot with it yet, although it's very intriguing because even now we're running into RFC 1918 issues. Overlap. When we acquire a new company, there's IP overlap. There's all kinds of annoying things that come along with that. So yeah, we absolutely want to investigate that.
Including occasional old curmudgeon-y developers or systems guys that use IPv6 like a swear word, and it's kind of frightening sometimes to switch over. So,
yeah, and there's obviously
that'd be the dream, but
yeah, again, I think it's not just about Talos, or we'll get to Sidero Metal. It's also about the network. And I think Sun Microsystems, I'm kind of dating myself now, used to have a slogan that the network is the computer. And I think that still really applies right now, because without the network, you've got nothing. You need to have a proper network to run these clusters and have them operate efficiently. And I think also running this on bare metal enables you to be the master of your own network. You're able to kind of tune it and hone it and run it the way you want, especially when you've got a low latency like we do. It's really important. And the fact that just running Kubernetes on its own gives you the ability to run different CNIs. You can really tune that. I know people were talking about Cilium earlier. We want to look into that. That's something else we want to find that might have feature parity with KubeRouter. But old school BGP and the effectiveness of console, being able to get to services quickly and easily without any extra overhead is really, really important. And it's also easy for other people to understand. So that's really why we chose Talos to start with. Very easy to install, super lightweight. KExec is awesome. So when you're installing, you don't even have to reboot the box after you've installed the operating system. And so with that, we were pretty happy with sort of our hand-built Talos cluster. And we knew at that point we needed to move into something where we could pull up hardware and be able to deploy it really with just push-button deployments, where we really could run one command and it would just work. We wouldn't have to deal with any of the bare metal provisioning side of it, the headache of trying to install an operating system and then go through the work to try to get it to run what you want, which in the past was a bit of a headache. So with Sidero Metal, it was really easy. We just grabbed a VLAN. We run VXLAN, so it's really easy to take a VLAN and just have it span across any number of cabs in a data center. Again, we were limited on hardware. We had to work with a lot of older hardware, also with newer hardware, and we were able to easily classify that using server classes. So you can basically read some of the metadata on the box and then pull it in and classify it, and then add those workers as needed into whatever clusters you want. And it made it really easy to do that. deploying Kubernetes with Kubernetes. So that means in order to, I think in the beginning, Andrew mentioned how if you wanted to deploy Cedero in your data center, you would sit there with a laptop, you deploy a single node Kubernetes cluster with Talos, just spin up one Talos node, and then install the Cedero control plane onto it. And then using that, you then build your first full-blown Kubernetes cluster, maybe on bare metal of, I don't know, 5, 6 boxes, whatever you want to start with, and then actually migrate the control plane over to that full-blown cluster. And so we love tools that can run in Kubernetes, even if it's bare metal provisioners running Kubernetes, or traditionally old school services like DHCP. Maybe those can run in Kubernetes. Think of new ways of sort of moving those out of the old way of thinking into running in Kubernetes, not just sexy new microservices that you guys are coding in Rust or whatever. So that's one of those features that I really liked. Also, the ability to fairly easily go in and just tune the kernel and add extra modules. Sometimes we'll have new hardware that comes in and it's got a brand new NIC in it that's not, for some reason, just wasn't, support for that wasn't added, or perhaps there's new drivers. It's fairly straightforward to add support for that. So we were able to very easily do that with Cedero Metal, and it made it really, really easy. So there were still some things that we wanted to do, and I'll send this over to Sean in just 1 second. How are we doing on time here? Okay. We had some customizations we wanted to make, namely being able to save ourselves the cost of running the control plane nodes on bare metal. Because again, at that point, we had limited hardware, and every bit of hardware we had, we wanted to use to serve ads and work with our stack, and not necessarily waste it on just control plane nodes that really aren't cracking away or doing much. They just kind of need to be there. So we wanted to do that. Also, we wanted some IPMI control over VMs, because we wanted to use VMs for control plane. And we wanted the way that the boxes get deployed, bare metal with Cedero Metal, to also be the same deployment method for VMs. And we felt that if that was different in any way, it just wouldn't really work the way that I think Cedero Metal was designed to work. So we needed to be able to do that. Also, automatic IP assignments of all the nodes, and automatic DNS record additions and things like that. That was all done. Everything that in the pipeline to deploy these boxes needed to be done using API calls. And then also we on each node we have kuberouter, which is essentially just BGP. It's Go BGP, and that needs certain annotations to run correctly, like your BGP peers. So when you connect to your top rack switches, your pod IPs and your cluster IPs, service IPs, things like that get advertised to announce properly. So yeah, Sean, if you want to take it away from here and talk a little bit about what you did to kind of make all this stuff work, that'd be awesome.
I didn't do everything, but there were a lot of different systems that had to come together all in different ways. Everybody's got their own way of naming things, and then you have to tie everything together with some type of tooling. We've all done stuff in the past that you do everything that you can and whatever kind of sinful practices that you want to in the name of getting it to work. In my case, most of my sins were committed with Python. In this case, we had a bunch of scripts that template out Terraform to deploy VMs just to make it easier. And at the end of the day, it was all about just, trying to apply some kind of consistent principles so that we could have the same level of abstraction that Talos and Cedero would offer, so that we can have servers as objects, so that it doesn't matter if your control plane is made out of bare metal or VMs, it gets treated the same way. Yeah, at that time, the biggest, vSphere, first-class vSphere integration was just a dream at the time that we started. I think our first cluster was Talos was 0.7 something at the time. So we had to cobble together this Rube Goldberg of Terraform and Python and Ansible and Bash and another Python thing and all sorts of other stuff.
Yeah, and again, we found virtual VMC. I think Andrew mentioned that earlier today, which basically effectively gives you virtual IPMI control over VMs. In our case, vSphere. So as you know, I'm not sure who's used Sidero Metal and who's not, but when a Sidero Metal, or let me start from the beginning here. Basically, what we needed to do was take a box anywhere on our network, have somebody make sure that it's on the proper VLAN, which would be a dedicated VLAN for this project for running boxes in Kubernetes and on Sidero Metal, which eventually we wanted to automate. Make sure it's on the proper VLAN, turn it on. It automatically gets detected by Sidero. We then accept it into the pool. And if it's not at that point allocated for a specific Kubernetes cluster, it will just power off. And so the same thing would happen with VMs using virtual VMC. It would literally power the VMs off as well, just like it would bare metal. You provide a username and password. We had at this point, it was Docker Compose running virtual VMC, and there were IPs mapped. That we actually literally had virtual IPs mapped to specific. I think there were different ports in virtual VMC, and that would be the IPMI address. That would be the VMC. So logically, it was really the same way we do it for bare metal, and that made it a little bit easier for us to understand how it worked, and it just allowed us to give complete control to Sidero Metal and spin up a cluster. So at that point, once we had that wired up, I'll take it over to the next slide here. This is really what it bought us. It was the ability to design a cluster decoratively through a YAML file. And Sidero Metal will read that YAML file. It's comprised of various definitions of, say, how many workers you need, how many control plane nodes you need, the type of workers, the type of control plane nodes. Again, you can have more than just one type of node in a control plane, or also as in your worker pool in a cluster. So you can have multiple types of hardware in there depending on what your needs are, and you can scale them independently. So to build a cluster at this point using our setup, you could run this one command right here, and 20 minutes later, you'll have a cluster up and running. It'll just be running. You don't have to do anything else. You'll grab a qconfig. There's some Talos cuddle commands you can run, grab the qconfig off of it, and then you're ready to rock and roll. Also, once you've got that cluster up, and say you have a scaling need, you can run another command here where you're just scaling that one machine deployment. So if you have 20 workers and suddenly you need, I don't know, 10 more, run one command, and that will wake those boxes up if they're in the pool and there's enough of them of that worker type, and you'll be able to very easily pull those into the cluster. It's just that one command. So wait about 5-10 minutes, and suddenly you'll see 10 extra nodes in the cluster, and that's all you'll have to do. Again, and those nodes in the beginning were just powered off. So at that point, it made our lives a heck of a lot easier. We didn't have to go through any type of other sort of antiquated bare metal provisioning system. There was no more cube spray playbooks to run or any goofy config management to have to deal with. It was just a single command. So it made our lives a heck of a lot easier. And so the future right now, really, we try to, and as of late, we have people in-house where we're asking for stateful storage, where we're trying to get apps that are traditionally stateful, of stateful nature. We're trying to pull those into the fold and move more and more apps into Kubernetes. So we're looking at different projects. We've already experimented with OpenEBS, with Jiva. I've looked at MyStore, and we're actually going to be looking at LinStore pretty soon. Again, a lot of what we do, we want to use KB stores for some of this, depending on the type of data that's distributed in nature to start with. So we don't necessarily want to have to lean on stateful storage unless we really have to. But that's something that we're looking at. Also, obviously, there are more and more apps right now, especially through the acquisition of Amobi, that we need to move into Kubernetes. So to do that, it requires building bigger clusters, spending more time and trying to port apps over. Some of these apps are, of different nature. They're not necessarily microservice based. Some of them are. So there's challenges with that. And again, as alluded to earlier by Steve and I think some other folks, we want to find a good way to burst into the cloud, a real intelligent way to do that. We've looked at kubespan. We've experimented with BGP. We want to really, I think, probably bring our clusters into more of the layer 3 fold, where we have less reliance on, say, the Talos API running on layer 2, and just bring everything straight layer 3. And again, I think Cilium could help with some of that as well. I think there's some feature parity between Cilium and KubeRouter now as far as its BGP capabilities. So Yeah, and I'm sure I'm forgetting things, but this is kind of where we're at right now. And with that, I think that's it. So I just want to thank Andrew, Steve, and everybody else. Andre, you're super helpful. You guys have been awesome. And if anybody wants to reach out to us, feel free. There's our email addresses. And also, we're hanging out. We're usually hanging out on the Sodero Slack, on the Slack team.
Awesome. That was super interesting. You guys have evolved a lot in a very short period of time.
Yeah, it's been a really amazing trip, and I feel like it's important to spend time on this bleeding edge type of this type of work. I mean, we're always striving to integrate new tools into the fold, and I think we have to. And it just keeps work exciting too. And we love working with you guys. So.
Yeah. Couple of comments about the storage. Craig suggesting Topo LVM.
Okay.
And
cool.
He knows a lot about storage. I will say that. I won't say where he's from, but he knows an awful lot about storage. And Dinesh is also suggesting to reach out to them at Civo about storage.
That'd be awesome. Yeah, we could absolutely use the help. And if you know, storage can be a headache from the days of NFS, DRB. There's all kinds of various storage attempts over the years, lots of proprietary stuff. And some of them have been great, some of them have been terrible. So we're hoping to find something that's really straightforward, easy to use, minimalist. It fits into our philosophy, our design philosophy, where it's easy to understand and not this Rube Goldberg contraption. So I'd love to reach out to you guys if you're able to help us out. That'd be great.
Yeah. So maybe you, Craig and Dinesh, you can reach out to BJ on Slack or something. How much?
That'd be great.
How much have you saved by moving to bare metal from cloud?
Oh boy. Well, it's a trade-off because obviously data centers are expensive to run. They're expensive to run in not necessarily a monetary way, but a personnel, a resource way. So you need to make sure you've got enough people that know how to deal with data centers and run them correctly and efficiently. And also make sure that your apps are easily deployable and portable, so you can run them wherever you want. It doesn't matter in the cloud or in the data center. I know we've saved quite a bit. I can't tell you exact numbers. I'm sure it's in the millions easily. I can't imagine running our workload in the cloud right now versus what we're doing on bare metal. Also, performance-wise, if EC2 instances, they're running under a hypervisor, right? So you're not getting bare metal performance. You're going to get sort of watered down performance. You're also getting hyper-threaded EC2 instances, I think with the exception of the Graviton instances. So again, with bare metal, you're getting a heck of a lot more bang for the buck. And you can get a heck of a lot longer shelf life off of boxes you've already paid for. So you can put those, even the slower boxes, you can classify them a certain way and run certain workloads on them that don't require fast CPUs or lots of memory or what have you. So,
yeah, and data transfer also is a little bit of a special consideration with the traffic that we have to deal with, right? Like the sheer volume of how many requests that we have to service and everything else. We move services from one place to another, then we've got data moving back and forth in both directions. That, of course, if you're on a cloud platform, then you're going to pay for that data transfer either way.
Yeah, data transfer is huge as well. Eric was asking about CabV. I haven't dabbled with that at all. Right now, all we've done is basically just use virtual VMC and be able to manipulate VMs using that. Creation of VMs, that's something we would love to use that for. I believe that can do that. Versus what we did, we were just basically building a pool of VMs that would sit there in the pool. We'd build those through Terraform. So it wasn't as sexy as doing it all from kubectl, but it did serve the purpose pretty well. And then Dinesh was asking about migrating from kubespray. Yeah, it wasn't much of a migration because as long as it's supported, as long as Talos and Sodero Metal supported the core services that we needed to run in Kubernetes, it ran fine because it's all Kubernetes at the end of the day.
All right, awesome. Andrew and I have to jump off and go announce Omni, which you guys are well aware of, but we've got that scheduled for 13 seconds from now. So that was awesome. Really appreciate the talk. That was thanks very much. Very interesting, and thanks a lot.
Thanks a lot, guys. Thanks, Steve.
Thank you.
Take care, everybody.